Now, the beauty of this calculator, they figured everything out for any distribution that we use, and they programmed it, all the formulas in. We just have to get used to how to access those. If we survey 200 students, and I ask the probability that between 113 and 184 students are new, how would you find your answer? So it's going to be a lot of work. You would find the probability distribution from 113 to 187 and add them up. That's a lot of work. So basically, on a number line, I will have to go to 113, 114, all the way to 187. That's a lot of trials, even with a calculator. So PDF tells you the probability distribution function. We have another function called CDF. CDF stands for cumulative. This cumulative distribution function for binomial specifically. We have it for other distributions as well. On a TI 86, 83, or 84, we're using 84, we're going to go to the same distribution, but we're going to go for not the PDF distribution, not the first one, the second one. PDF is the first. CDF is, as you see, Poisson PDF, Poisson CDF, Geomet PDF, CDF, chi-square distribution, PDF, CDF, that's chapter 11. F distribution, there's PDF, CDF for all of them. So when you want the CDF, the cumulative you're adding, it's that one. I'm gonna get out of that for a minute and tell you how to use that. This is how it works. Whenever you're looking at x being less than a number, less than or equal, you use the binomial CDF. This number right here is that number right there. So this only works for less than. So when I'm looking at no more, at most, less than, if I make this b, right? So this is the probability that x is less than or equal to b. Then that works. I will use binomial CDF, and I would use n of trials, number of trials, probability of success, and I would use b in that case. If you see fewer than, less than or equal, right? Fewer than, let's say a is right there and b is right there. If they say, what's the probability that x is fewer than or less than a? If the first integer to the left of a is b, then that's the same thing. What if we go the other way around? What if we want at least, no less than, greater than or equal, and let's say a is right there and b is right here. Actually, I'm sorry. In this case, let's say b is right here. This is the probability that x is bigger than or equal to b. Same deal, identically, if I was to put a right there and b right there and say, hey, more than a, greater than a, what's the probability that x is greater than a? Notice the equal is not there. So the first number greater than will be b, right? Or you could start with it. Since the calculator only works to the left, we would say, well, look, if you're going to go from b all the way up, the complement to that is 1 minus the probability that x 1 minus binomial CDF and P and B. And that's how we're going to use this. Now when I look at the second page, I have some examples so that we could reinforce this. There it is. And let's get straight into it. We start off with a basketball player can make 75% of free throws he tries. Probability of success is 0.75. If the player attempts 10 free, so this player makes 75% on average. He throw the first, the second, the third. If he tried 10, find the following probabilities. What's the probability that he will make at most 6? Isn't that less than or equal to 6? Instead of me saying, well, that's x equals 0, he makes none, or 1, or 2, or 3, or 5, or 6, and add them up, I have, and I'm going to get out of it and do it again, I have this function in my calculator, distribution, binomial, CDF, cumulative. Now they're asking me, okay, this is a binomial CDF, how many trials we have? 10. What's the probability of success? 75%. What value are you looking for? To the left of 6. Paste and tell me what that number is. 22.41%. Now on a test, all what I have to do is copy what's on the calculator and we're pretty much set. And there it is. Done deal. Very simple. So, a big portion is gonna be whether you know how to use a calculator or not. So make sure you have the calculator as you do the homework and make sure that you bring it in when you take your test. How about here? The player will make at least, now you gotta make this out. When you say at least, put it in your head, at least 8. Is 8 included? That's the question. We know there's an x and an 8. Is it included? Well, at least 8, that means 8 or 9 or 10, bigger than or equal. I could plug in my calculator, and I could show you really quick, just to demonstrate. I could plug in my calculator and do each one of those. I could say, you know what, there's only 3 of them, 8, 9, and 10. I could do CDF, a PDF, right? I could say, well, distribution, just to show the main use of this. The number of trials is 10. Probability of success is 0.75. I want x to equal exactly 8. Plus, over here, I'll do it, 8. That's going to be probability that x equal 8. Or, you add 9. Or 10. Well, this happened to be that number, 0.2815 0.28157 plus, if I go to 9, I'm just going to go back, even though that might seem like not a lot of work, which is, it's not really. 18771 plus, and I go for 10, I go back, and of course that's not what we want you to do, but 0.56313. Now if I add all of those, if I get my calculator and take 0.28157 plus 0.18771 plus 0.056313, I'm getting 525593. 525593. Or guess what? Instead of doing all of that, I'm going to say that's 1 minus binomial CDF of what? Here's the catch. Draw the line 8, 9, 10. What's the complement to that? Isn't that 10? So the complement to that, isn't that probability that x is less than or equal to 7? Because those are not included, what's left. So if I put this in my calculator, instead of doing what I just did, all of that work for no reason, I could have went in and said second distribution, go to cumulative instead of the binomial 3 times or 4 times. Here it is. Number of trials, we have 10. 0.75 success, and we want 7. Okay, something didn't add up. Oh, 1 minus that. I'm sorry. 1 minus right? Insert 1 minus. There it is. And what do you notice? And this is a lot more efficient. You do get the same answer. What's the point of doing all of this work? So definitely use this. And how about this problem? According to 2017 Washington Post article, approximately 53% of all U.S. households are wireless-only households, meaning they don't have any landline. In a random sample of 20, n equals 20, p equals 0.53. I don't need q yet. Q is 1 minus that, 0.47. I don't need it in my formula for my calculator. I will need it for something else though. Find the probability. When they say fewer than 6, doesn't that mean this is 0, this is 20, if this is 6, 5, fewer, doesn't that mean you start at 5 and you go all the way down to 0? So isn't that x is less than or equal to 5? So you need the equal for this binomial CDF to work. And now to my calculator straight, that much to do. In this case, I have binomial CDF. I want the number 12 to be 20. Probability of success 0.53. And we said 6 or 5, I forgot. 5. There it is. Solve it for me and it gives me the answer. And I'm done. I am sorry, just a bit having a hard time with the technology, and the PDF is, I could use Word, but I can't control those as much. Word would be nicer and the writing would be nicer too, but that's okay, that's more price to pay. And how about part B? It says, how about the probability that more than, if this is 13, you say more than, is 13 included? Isn't that x more than 13? What's the complement to that? Isn't that 1 minus the probability? What would be everything beneath? Isn't that x is less than or equal to 13? So I could throw that in my calculator, but I gotta plug it in as I see it. 1 minus distribution. I want to go to, so I suggest you do that as many times as it takes on the homework until you get the hang of this. This is the same, this is the same. I just need that to be 13. Paste, tell me what the answer is. There it is, done deal. So I will teach you everything you need about a calculator. You just have to make sure that you bring it in and practice enough with it. That was my phone, I apologize. Okay, here we are. So again, nothing more than using a calculator. You have that on the homework. We'll play with it. You'll play with it, and if you have any questions, I'll go over that next class meeting. Now we do have formulas, and those are provided on your test. You probably already saw them in the formula sheet that I told you I was going to provide. Using mean and standard deviation for critical thinking. The mean formula for binomial distribution is n times the probability of success. And the standard deviation is the square root of npq. Remember, q is the probability of failure. Round off rule the same as before. In this case, we're going to round to the nearest tenth. So here's an example. According to the U.S. Office of Adolescent Health, nearly 90% of adult smokers in the U.S. started smoking before they were 18. So 90%. What's Q? Q is 10%. If 300 adult smokers are randomly selected, n equals 300. How many would you expect to have started before turning 18? Well, the average should be, in this case, NP. That should be 300 times the probability of success. We would expect 290 of them to have 270. I can't multiply. Anyway, you're going to do that on a calculator, right? Don't do any of this by hand. 270 smokers. We would expect out of the 300, 270 of them have started before the age of 18. And if they say, would it be usually significantly higher or low to observe 240 smokers who started smoking before 18 in the random of 300? Well, how are we going to figure that out? We know the average is 270. We know the standard deviation is the square root of n times p times q. The standard deviation is the square root n times p times q. 5.2. So how do we do this? Well, we know how to do this. We say take 270 and subtract 5.2. That's one standard deviation and another 5.2. So that is 264.8 and 259.6. Do you see that 240 smokers are below 2 standard deviations? Right? So we say unusual. There's another way. If you remember, Z would be X minus the average divided by the standard deviation, or X minus the average divided by the standard deviation. That tells you how many standard deviations above or below the mean that is. If I plug that in my calculator, what do I get? If I take parentheses 240 minus 270 divided by 5.2, negative 5.8 standard deviations. Heck, that is really unusual. And that's pretty much it for this section.